So let's do another example of graphing using transformations for a sinusoidal curve. This time we're going to have y is equal to -2 times the cosine of pi x. You'll notice that this takes on the form y is equal to a times the cosine of omega x. This lets us know, first off, what our mother function is. The mother function is going to be y equals the cosine of x. Additionally, you will see an amplitude modulation as well as a frequency modulation for this. For the amplitude modulation, that is simply going to be multiply all of your y values by the a value that we reference as the coefficient. So this will be multiply y by -2. Now when we multiply y by -2, that's actually going to be both a stretch as well as a reflection. However, the only thing that is reflected in the stretch, no, I'm sorry, that was a terrible joke. Forget I said that just now. The only thing that has an impact on the actual amplitude is the stretch, which is why we incorporate those absolute values as part of identifying the amplitude. So in this case, that would be the absolute value of -2, which is +2. As far as the frequency modulation is concerned, what we'll do is we'll say that one period goes from 0 to 2 pi, and the thing that goes in the middle is whatever our angle happens to be. The angle is always what you have inside the parentheses, so that would be pi x. Whatever you do to solve this for x, that will be your frequency modulation. What we're going to do is divide all three parts by pi. So the frequency modulation is going to be to divide x values by pi, letting us know that one period is going to start at 0 and is going to end at x equals 2. So the period, or wavelength, will be equal to 2. You'll notice that that's consistent with the formula that we had of 2 pi divided by omega, because in this case omega was equal to pi. Next, we'll actually put down some points for our mother function. Y equals the cosine of x. X values will be the quadrantal angles from the unit circle, and y will be the corresponding value of the cosine of each of those angles. This will start at 1, then go to 0, -1, 0, +1. We'll start with the frequency modulation and have an impact on the x values. The frequency modulation is divide everything by pi. What that winds up doing is simply canceling out the pi's that are present in each of these angles. So corresponding x values will be 0, 1/2, 1, 3/2, and 2. We can also do an amplitude modulation. And the amplitude modulation was, we're going to multiply all of our y values by -2. That is going to create both a reflection as well as a stretch. So what was 0 will stay as 0. What was positive will become negative, and what was negative will become positive. I said this for the last example, I'm going to say it again. The majority of this section is just drawing the same picture over and over, just changing what the scale happens to be equal to. So x values are 1/2, 2/2, 3/2, and 4/2, reducing the fractions wherever appropriate. So, corresponding points are 0, -2, starts at a minimum, then 1/2, 0, up to the midline, then 1, 2, up to the maximum, 3/2, 0, back to the midline, and 2, -2, back to the minimum. To create your graph, we want to try to make sure that it doesn't wind up too pointy. So starting at those maxima and minima and curving into the other points will be the way to go. Now this does only show off one cycle, so we'll have to follow the pattern to figure out 4 more points on this. I mentioned earlier, this is 1/2, 2/2, 3/2, 4/2, keep that pattern going, 5/2, 6/2, 7/2, 8/2. and then reduce wherever appropriate. We started at a minimum. Now we go back to the midline, up to a maximum, down to the midline, and then back down to a minimum. And again, we'll connect these points just like so. Now we know that this is going to continue in both directions, so we'll toss little arrows at the end of both of those. Now, as a bonus, we'll identify the domain. I know that this thing extends forever to the left and to the right, so the domain will be all real numbers. The range will go from the lowest point on the graph to the highest point on the graph. In this case, that will be -2 to +2.